Okay. So again, page 14, we filled in last time the unit circle in both degrees and radians. Again, we will need to have these angles memorized. After we finish the notes, we're just going to spend time today on different activities to kind of make sure we know where these things are. If we know where these things are in degrees and radians, it's going to make a lot of other trig things a whole lot easier than they might be otherwise. So we filled these in yesterday, and we can now use these to very quickly, on page 15, do conversion problems Page 15, we can use these to quickly do conversion problems of good angles that were around the circle without having to go through our conversion formulas. Here's what I mean by that. On page 15, I want you to convert 60 degrees to radians. Look at page 14. 60 degrees is what? Pi over 3. That's all we're doing. We're locating one in degrees and telling me how it's also labeled in radians. Go convert 135 degrees. And then stop, don't do C. $135 degrees is what? 3 pi over 4. Now, 120 degrees. We have to, sorry, not 120, negative 120 degrees. We've got to talk about that. Okay. I know that 120 degrees is over here. So I know that negative 120 degrees is over here. I am not, however, going to say that the answer is 4 pi over 3. Fiona? No, but you're on the right track-ish. Here's the deal. Negative 120 degrees, watch this closely, please, is the angle that starts here and goes like this. 4 pi over 3 is the angle that starts here, goes like this, and ends up there. They're coterminal, but they're not the same angle. What is 120 degrees in radians? 2 pi over 3. Negative 120 degrees is just going to be negative 2 pi over 3. It's the same angle, just with a negative on it. I'm not looking for a coterminal angle. I'm looking for something that spun the same way to get there. So just negative 2 pi over 3. That's it. Basically, ignore the negative, convert, and then stick a negative on the answer. Do D very quickly, and then I feel like you don't need explanations for the next 4. I think you can figure those out on your own. The ones in radians that we're going to degrees on. And ultimately, the goal is not to really have to look at page 14 to do these. We're just going to know where these angles are. Okay, I know where 11 pi over 6 is, and I know that's in the same place as, well, this thing in degrees, so I can just write that without having to look at that. What's D? What's negative 180 degrees? Just say it. Negative pi. Okay, 11 pi over 6. My favorite angle. What is it? 330 degrees. 4 pi over 3. What was that? 240 degrees. Negative pi over 2. Negative 90 degrees. Just do pi over 2. That's 90. Make it negative. Negative 5 pi over 4. Negative what? Negative 225 degrees. Negative 225 degrees. Easy enough. Last thing we need to look at. Coterminal angles. Remember from our first day with angles that coterminal angles are angles that end in the same place. So like this angle and this angle are coterminal. They're very different. You get there in different ways, but they end in the same place. We found them in degrees by doing what? Adding or subtracting? 360, one complete time around the unit circle. I'm not going to do that in radians. What do you think I'm going to add or subtract? Lionel? 2 pi. We're just going to add or subtract one time around the unit circle. So I think below the title, very small, because there's a little bit of room there, we're going to say to deal with this in radians, we are going to add or subtract multiples of 2 pi. And the whole multiples part means just do it once and maybe do it again if you need to do it a second time, do it a third time if you need to find a positive and a negative angle. So I want to do the problem 2 pi over 3 plus 2 pi. Does anyone have a problem with that? We need to get a common denominator. Okay, well, I'm adding 2 pi over 1. We're actually going to see in a moment this is actually going to be even easier than doing it in degrees because the numbers are going to be smaller. I'm not really going to add 2 pi over 1. What's the common denominator version of this I should really use? 6 pi over 3. I want something over 3. Well, 2 pi over 1, you can multiply the top and bottom by 3 and turn that into 6 pi over 3. I can do the rest without a calculator. 2 pi over 3 plus 6 pi over 3? 8 pi over 3. That's my positive coterminal angle. I also need a negative coterminal angle, so I'm going to do 2 pi over 3 minus 6 pi over 3. And that's going to give me negative 4 pi over 3. That's all we're doing. In the homework, the directions will clearly say do these in radians. I'm not looking for you to convert these to degrees and then do plus 360 minus 360. I want you adding or subtracting 2 pi, but really you're going to have to do it with a common denominator so things are going to work. Next, 7 pi over 4. I need to add 2 pi. What do you really want to call it, though? 8 pi over 4. And I'm also going to go and subtract that. Go finish B, and then do C and D on your own. Hopefully you got 15 pi over 4 and negative pi over 4. What are you doing with negative pi over 6? What are you adding or subtracting? 12 pi over 6, I hope? Maybe? Okay. This should give us 11 pi over 6 and negative 13 pi over 6. What are you going to use with 5 pi over 2? 4 pi over 2. So we can add 9 pi over 2. We can go and we can subtract pi over 2. Good? What's wrong? My directions said give a positive answer and a negative answer. I didn't say add once and subtract once. I want the final answers to be positive and negative. The positive answer, 9 pi over 2 is good. Pi over 2 also works as your positive answer. But I've got to get a negative answer. Lionel. This is like before when we would subtract 360. Not good enough, so take your answer, subtract another 360. Same thing here. I'm going to take that answer of pi over 2. I'm going to subtract 4 pi over 2. And a negative answer is negative 3 pi over 2. Which should be fine unless you felt like going further and you could do it again and again and again. And all I need is a positive and a negative, and we're good. Those of you who for some reason did this part of the homework, please do it again in radians, adding or subtracting multiples of 2 pi. Get a common denominator. Not super difficult, but just make sure we can do that. Any questions? Okay, so first I'm going to shut this off.